NVIDIA. This is just one crazy company. Their stock has gone up more than 10x since their low in 2022, and they just keep on growing and moving so fast. So today, CEO Jensen Huang had a keynote in Taipei where they made a ton of major AI announcements. So as always, I'll play you condensed clips from the event, and I'll explain everything in simple terms so that you can understand it easily. Let's jump right in.
We could interact with these AI services with text prompts and speech prompts. However, there are many applications where we would like to interact with what is otherwise a human-like form. We call them digital humans. NVIDIA has been working on digital human technology for some time. Let me show it to you. And well, before I do that, hang on a second. Before I do that, okay, digital humans has the potential of being a great interactive agent with you. They make much more engaging. They could be much more empathetic. And of course, we have to cross this incredible chasm, this uncanny chasm of realism, so that the digital humans would appear much more natural. This is, of course, our vision. This is a vision of where we love to go. But let me show you where we are.
Great to be in Taiwan. Before I head out to the night market, let's dive into some exciting frontiers of digital humans.
Imagine a future where computers interact with us just like humans can.
Hi, my name is Sophie, and I am a digital human brand ambassador for Unique.
This is the incredible reality of digital humans. Digital humans will revolutionize industries, from customer service to advertising and gaming. The possibilities for digital humans are endless.
Using the scans you took of your current kitchen with your phone,
they will be AI interior designers, helping generate beautiful, photorealistic suggestions and sourcing the materials and furniture.
We have generated several design options for you to choose from.
There'll also be AI customer service agents, making the interaction more engaging and personalized, or digital healthcare workers who will check on patients, providing timely, personalized care.
I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medications?
The antibiotics you've been prescribed, ciprofloxacin and metronidazole, don't contain penicillin, so it's perfectly safe for you to take them.
And there'll even be AI brand ambassadors, setting the next marketing and advertising trends.
Hi, I'm Ima, Japan's first virtual model.
New breakthroughs in generative AI and computer graphics let digital humans see, understand, and interact with us in human-like ways.
From what I can see, it looks like you're in some kind of recording or production setup.
The foundation of digital humans are AI models built on multilingual speech recognition and synthesis, and LLMs that understand and generate conversation.
你们部落有什么特别的习俗吗？
我们有丰富的祭祀仪式和传统舞蹈，还有对大自然的崇拜。
The AIs connect to another generative AI to dynamically animate a lifelike 3D mesh of a face. And finally, AI models that reproduce lifelike appearances, enabling real-time path-traced subsurface scattering to simulate the way light penetrates the skin, scatters, and exits at various points, giving skin its soft and translucent appearance. NVIDIA ACE is a suite of digital human technologies packaged as easy-to-deploy, fully optimized microservices, or NIMs. Developers can integrate ACE NIMs into their existing frameworks, engines, and digital human experiences. Nemotron SLM and LLM NIMs to understand our intent and orchestrate other models. Riva Speech NIMs for interactive speech and translation. Audio to face and gesture NIMs for facial and body animation. And Omniverse RTX with DLSS for neural rendering of skin and hair. ACE NIMs run on NVIDIA GDN, a global network of NVIDIA accelerated infrastructure that delivers low-latency digital human processing to over 100 regions.
All right, so this is a showcase of NVIDIA ACE. ACE is a toolkit that helps create digital avatars that look and behave like real humans. So these characters can talk, understand language, and even show facial expressions and body gestures. They can be used in a variety of applications, including video games, customer service, and healthcare. So here's how NVIDIA ACE works. There are a few components to NVIDIA ACE. So the first component is called NVIDIA Riva, and this basically helps the avatar understand speech and speak different languages. So it's basically an AI for speech recognition and text-to-speech. And then we have their Nemotron LLM. This is a large language model similar to GPT, and it helps the avatar understand what you're saying and respond appropriately. And then the next component is NVIDIA's audio-to-face. So after this LLM digests your input, it outputs an answer, which is spoken by this avatar, and then this algorithm, this audio-to-face, basically makes the avatar speak the output. So it makes the face move realistically when it talks. And then we have the Omniverse RTX. The Omniverse is basically a digital replicate of the real world. So it replicates all the physics of the real world, including gravity, including how light moves, including how liquids move. And so with this Omniverse technology, it makes the character's skin and hair look very realistic. You can see here how they shine the light on this person's skin. It's just super realistic and very high quality. And then these two are not available yet, but it's coming soon. So they're also going to introduce this component called audio to gesture, which makes the digital human move its body as well. So not only is its face speaking out the output, but his or her body is going to be more fluid. And then they're also introducing this Nemotron 4.5 billion parameter small language model. So large language models like OpenAI's GPT, for example, they're over 1 trillion parameters. A small language model is only 4.5 billion parameters in this case. So this is a super small AI that can live on your device. As you can see here, this is used for on-device inference. So eventually you don't even need to connect to the internet or to the cloud. You'll have an AI model built into your device. Now, with these human avatars, of course, they can be added to a ton of different products or services to make them more interactive and lifelike. So for example, this could be used to create characters in a video game or be used in customer service. Or imagine this digital human living on your computer, and instead of you using a mouse and keyboard to navigate through things on your computer, you just talk to this digital avatar and it would carry out everything for you. This could very well be the future of personal computers.
And now we have a new factory, a new computer. And what we will run on top of this is a new type of software. And we call it NIMs, NVIDIA Inference Microservices. Now what happens is the NIM runs inside this factory. And this NIM is a pre-trained model. It's an AI. Well, this AI is, of course, quite complex in itself. But the computing stack that runs AIs are insanely complex. When you go and use ChatGPT, underneath their stack is a whole bunch of software. Underneath that prompt is a ton of software. And it's incredibly complex because the models are large, billions to trillions of parameters. It doesn't run on just one computer, it runs on multiple computers. It has to distribute the workload across multiple GPUs, tensor parallelism, pipeline parallelism, data parallelism, all kinds of parallelism, expert parallelism, all kinds of parallelism, distributing the workload across multiple GPUs, processing it as fast as possible, because if you are in a factory, if you run a factory, your throughput directly correlates to your revenues. Your throughput directly correlates to quality of service, and your throughput directly correlates to the number of people who can use your service. We are now in a world where data center throughput, utilization is vitally important. It was important in the past, but not vitally important. It was important in the past, but people don't measure it. Today, every parameter is measured. Start time, uptime, utilization, throughput, idle time, you name it. Because it's a factory. When something is a factory, its operations directly correlate to the financial performance of the company. And so we realize that this is incredibly complex for most companies to do. So what we did was we created this AI in a box, and it contains an incredible amount of software. Inside this container is CUDA, cuDNN, TensorRT, Triton for inference services. It is cloud native so that you could auto scale in a Kubernetes environment. It has management services and hooks so that you can monitor your AIs. It has common APIs, standard APIs, so that you could literally chat with this box. You download this NIM, and you can talk to it. So long as you have CUDA on your computer, which is now, of course, everywhere. It's in every cloud, available from every computer maker. It is available in hundreds of millions of PCs. When you download this, you have an AI, and you can chat with it like ChatGPT. All of the software is now integrated. 400 dependencies all integrated into one. We tested this NIM, each one of these pre-trained models, against our entire installed base that's in the cloud, all the different versions of Pascal and Amperes and Hoppers and all kinds of different versions. I even forget some. NIMs. Incredible invention. This is one of my favorites.
So here Jensen mentions NIMs. NIM stands for NVIDIA Inference Microservices. These are basically services designed for enterprises to accelerate the deployment of their AI applications. They're essentially pre-trained AI models that are packaged and optimized to run very efficiently for enterprises. So, for example, they offer seamless, scalable AI inferencing. They can be used on-premise or in the cloud, plus they have APIs that you can call.
And so we installed every single RTX GPU with Tensor Core processing, and now we have 100 million GeForce RTX AI PCs in the world, and we're shipping 200, and this Computex, we're featuring 4 new amazing laptops. All of them are able to run AI. Your future laptop, your future PC will become an AI. It'll be constantly helping you, assisting you in the background. The PC will also run applications that are enhanced by AI. Of course, all your photo editing, and your writing, and your tools, all the things that you use will all be enhanced by AI. And your PC will also host applications with digital humans that are AIs. And so there are different ways that AIs will manifest themselves and become used in PCs, but PCs will become a very important AI platform.
Your future PC will become an AI. And I think this is very true. I think for future generations, we're going to use the mouse and keyboard less and less, and how we operate a computer would be more of like natural interaction with an AI language model. And this announcement is actually quite similar to Microsoft's announcement last week, where they unveiled their Copilot Plus PCs. This is basically their line of computers which has an AI built into it. So they have Microsoft Copilot, which is essentially GPT, integrated into a lot of different functions and applications directly inside the Windows operating system. Plus, all these PCs have an NPU, a neural processing unit, which is similar to NVIDIA's GPU, but it's more optimized for machine learning, and this chip can carry out all these AI functions directly on the device. So this was Microsoft's line of AI PCs, which they call Copilot Plus PCs. And then here, NVIDIA also announced their new line of AI PCs, which they call RTX laptops. So these laptops are built from a variety of manufacturers, such as Asus and MSI, and these have NVIDIA's RTX CUDA GPUs built in. So this allows you to run a variety of AI applications on your device, such as Ollama for running open source language models, or Stable Diffusion for image generation, or Crew AI, for example, if you want to program a team of AI agents. So NVIDIA is partnering with all these different laptop manufacturers to seamlessly integrate their RTX GPUs into these laptops so that us users can use these laptops for generative AI.
Today, we're excited to share Project GAssist, a demo showcasing how developers can enhance games and apps with AI assistance. This is where Project GAssist comes in. It uses AI to make sure information is readily available whenever we need it. It works by taking in speech or a text prompt from the player. along with context from the screen, and then it feeds this into a large language model that is enhanced by the developer's game knowledge database. These AI models can run on the cloud or locally, accelerated by your GeForce RTX GPU. To show you what's possible, we've partnered with Studio Wildcard for a tech demonstration using Ark Survival Ascended. The assistant is your conduit for game-specific knowledge. You can ask it questions you often find yourself looking up online, like, what's the best early game weapon and where do I find the crafting materials for it?
The best early game weapon is the spear. It provides knockback and is essential for survival.
Not only does it know about the game, it can understand what's happening on the screen. Maybe you're staring at a dinosaur you're not familiar with and you want to know what it is or how to tame it. And because the assistant is context aware, it can tailor its recommendations to your playthrough. Say you've racked up enough points to level up or to unlock a crafting recipe, but you're just not sure what to go for next. And if you want to dive deeper into a topic, you can simply click on the response to learn more at the official wiki, for instance. These are just a few of many examples. But gamers often need help outside the game, too. Modern titles demand peak performance from our systems for a smooth and immersive experience. But with how configurable PC gaming can be, figuring out how to optimize your particular setup is often not straightforward. The AI assistant understands your system and can help tune and optimize it for you. It can provide insights into performance metrics, like FPS and PC latency, for example, and chart these for you as you tweak your PC for more responsiveness. It can scan your system to see if there's anything out of order, like not taking full advantage of your display's capabilities. You can ask it for recommendations to increase performance or efficiency. It may suggest optimal graphics settings for your particular setup, or even overclocking, or finding ways to consume less power while maintaining a target of 60 FPS, for example. And it'll actually do these things for you.
Your system has been optimized for performance per watt with a minimum maintained frame rate of 60 FPS.
AI assistants will transform the way we engage with our favorite games and apps, and Project G Assist is a glimpse into that future.
All right, this function is really cool. So this is Project G Assist, and this is basically an AI assistant or a chatbot that helps you when you're like in a video game or you're using an app on your computer. So you can either talk to it with your voice or you can type in text input, and like a chatbot, it answers your questions. So it uses AI vision to scan your screen and understand what's going on inside the video game, for example. And then based on this AI vision and based on your question, it can provide the appropriate answer for you. In fact, this is very similar to Microsoft's demo last week where they used Copilot as a real-time voice assistant to help this user play Minecraft. NVIDIA's Project G Assist is essentially the same thing.
This is Earth 2. The idea that we would create a digital twin of the Earth, that we would go and simulate the Earth so that we could predict the future of our planet to better avert disasters or better understand the impact of climate change so that we can adapt better, so that we could change our habits now. This digital twin of Earth is probably one of the most ambitious projects that the world's ever undertaken, and we're taking large steps every single year, and I'll show you results every single year, but this year we made some great breakthroughs. Let's take a look.
On Monday, the storm will veer north again and approach Taiwan. There are big uncertainties regarding its path. Different paths will have different levels of impact on Taiwan.
想象一个我们能够预测未来的世界，数位孪生反映真实情况的虚拟世界，让我们看见未来。数位孪生是一种反映真实世界的虚拟模型，让我们能够从今天的行为来预测对未来世界的影响。介绍一下 NVIDIA Earth 2， 一个利用 AI、物理模拟和电脑图形技术来预测全球气候的数位孪生。 Core Diff 是 NVIDIA 的生成式 AI 模型，它在 WRF 数值模拟的基础上训练而成，能够以12倍更高的解析度生成天气模式，从25公里提高到2公里，这代表了区域天气预测的一个巨大飞跃。令人惊讶的是 ，Core Diff AI 比传统的物理模拟方法快1000倍，且能源效率高3000倍。在台湾的中央气象局是用这些模型来更精确地预测台风登陆点。但我们并不止步于此，下一个前沿是超本地预测，能精确到数十米，并考虑到城市基础设施的影响。Core Diff AI 还在使用像是 Palm 生成的高解析度数据进行训练，一个极高解析度的物理模型，用于模拟大气和海洋边界层。当与天气模拟风场结合一起时，它可以模拟建筑物周围的气流、当级强风汇聚的情况。我们预计能够预测像下冲这样的现象。当强风汇聚到街道层，会有可能造成损坏并影响行人。NVIDIA R2是一个绝佳范例，它融合了人工智慧、物理模拟和观测数据，可以帮助国家和公司预见未来，并应对极端天气的影响。
Someday in the near future, we will have continuous weather prediction at every square kilometer on the planet. You will always know what the climate's going to be. You will always know. And this will run continuously because we've trained the AI, and the AI requires so little energy.
Alright, so this is quite an insane project. This is called NVIDIA Earth 2, and they're basically trying to create a digital clone of planet Earth. And they're going to use this to predict weather and climate changes. It combines AI, physics simulations, and real-world data to make these predictions. Think of this as like a supercomputer that can look at all the weather data in the world, and by using AI, it can predict what will happen next. Now, I don't know about you, but my local weather forecast sucks. They get the weather wrong all the time, and I don't blame them. I mean, weather prediction is just extremely hard to get correct, even with all the amazing technologies that we have today. Now, with NVIDIA's Earth 2, we could get much more accurate real-time weather predictions, and this has many benefits. For example, this can help us prepare for extreme weather events and also help us understand the impacts of climate change.
Ladies and gentlemen, this is Blackwell. Blackwell is in production. Incredible amounts of technology. This is our production board. This is the most complex, highest performance computer the world's ever made. This is the gray CPU. And these are, you could see each one of these Blackwell dies, two of them connected together. You see that? It is the largest die, the largest chip the world makes. And then we connect two of them together with a 10 terabyte per second link. Okay, and that makes the Blackwell computer. And the performance is incredible. You see our, the computational, the flops, the AI flops for each generation has increased by 1,000 times in 8 years. Moore's law in 8 years is something along the lines of, oh, I don't know, maybe 40, 60. And in the last 8 years, Moore's law has gone a lot less. And so just to compare, even Moore's law at its best of times compared to what Blackwell could do. So the amount of computations is incredible. And whenever we bring the computation high, the thing that happens is the cost goes down. And I'll show you. What we've done is we've increased, through its computational capability, the energy used to train a GPT-4, 2 trillion parameter, 8 trillion tokens. The amount of energy that is used has gone down by 350 times. Well, Pascal would have taken 1,000 gigawatt hours. 1,000 gigawatt hours means that it would take a gigawatt data center. The world doesn't have a gigawatt data center, but if you had a gigawatt data center, it would take a month. If you had a 100 megawatt data center, it would take about a year. And so nobody would, of course, create such a thing, and that's the reason why these large language models, ChatGPT, wasn't possible only 8 years ago. By us driving down increasing the performance, the energy efficient, while keeping and improving energy efficiency along the way, we've now taken, with Blackwell, what used to be 1,000 gigawatt hours to 3, an incredible advance. 3 gigawatt hours, if it's a 10,000 GPUs, for example, it would only take 10,000 GPUs, I guess it would take a few days, 10 days or so. So the amount of advance in just 8 years is incredible.
So NVIDIA announced this Blackwell architecture in March at another event, GTC. So check out this video if you want to learn more about those announcements. But for here, he's also just showcasing this Blackwell architecture. Now, this is quite complicated, and there's a lot of configurations of this Blackwell GPU, so let's go over all of them. Now, this Blackwell chip is just incredibly powerful. This GB200 superchip consists of 2 Blackwell GPUs as well as 1 Grace CPU. The generation prior to this Blackwell ecosystem is called Hopper. Now, the Hopper chip, this is the most demanded commodity in the tech industry. So tech giants like Microsoft, Meta, Amazon, and Google, they have been just stockpiling these H100 GPUs because they need it for training their AI models, right? Compute is the main bottleneck right now in the AI industry. The more compute you have, the bigger and better models you can train. And so these H100 chips were pretty much sold out all the way up to like Q1 of 2024. But forget the H100. NVIDIA now has this Grace Blackwell superchip, which has 30 times better performance and 25 times more energy efficiency compared to the Hopper ecosystem. So this thing is just insanely powerful already, but it's not good enough.
Okay, so Blackwell is just an enormous leap. Well, even so, it's not big enough. And so we have to build even larger machines. And so the way that we build it is called DGX. So this is our Blackwell chips, and it goes into DGX systems. The benefit of this is that in one domain, one GPU domain, this now looks like one GPU. This one GPU has 72 versus the last generation of 8, so we increased it by 9 times. The amount of bandwidth we've increased by 18 times. The AI flops we've increased by 45 times, and yet the amount of power is only 10 times. This is 100 kilowatts, and that is 10 kilowatts. And that's for one. Now, of course, well, you could always connect more of these together, and I'll show you how to do that in a second. But what's the miracle is this chip, this NVLink chip. People are starting to awaken to the importance of this NVLink chip as it connects all these different GPUs together, because the large language models are so large, it doesn't fit on just one GPU, it doesn't fit on just one node. It's going to take the entire rack of GPUs, like this new DGX that I was just standing next to hold a large language model that are tens of trillions of parameters large. NVLink switch in itself is a technology miracle. It's 50 billion transistors, 74 ports at 400 gigabits each, 4 links. And so this is what a DGX looks like now. The back of this GPU is the NVLink spine. The NVLink spine is 5,000 wires, 2 miles. And it's right here. This is an NVLink spine. And it connects 72 GPUs to each other. This is an electrical, mechanical miracle.
So here is the DGX Blackwell SuperPod. In this case, you can basically insert 36 of these GB200 superchips. So this includes 36 Grace CPUs as well as 72 of these Blackwell GPUs. So you can basically insert up to 36 of those superchips into these slots here. And these superchips are connected as one supercomputer via something called NVLink. So this thing that he took out here, this is the NVLink spine. This is basically the linkage between all these 36 superchips so that they are connected as one supercomputer seamlessly. All right, so the DGX can house 36 GB200 superchips, and this is already great for training trillion parameter models. However, this is not enough. So he introduces something crazier.
Ethernet with Spectrum-X basically allows us to improve the performance so much that the network is basically free. And so this is really quite an achievement. We have a whole pipeline of Ethernet products behind us. This is Spectrum X800. It is 51.2 terabits per second and 256 radix. The next one coming is 512 radix, is 1 year from now. 512 radix, and that's called Spectrum X800 Ultra. And the one after that is X1600. But the important idea is this. X800 is designed for tens of thousands of GPUs. X800 Ultra is designed for hundreds of thousands of GPUs. And X1600 is designed for millions of GPUs. The days of millions of GPU data centers are coming. And the reason for that is very simple. Of course, we want to train much larger models, but very importantly, in the future, almost every interaction you have with the internet or with a computer will likely have a generative AI running in the cloud somewhere. And that generative AI is working with you, interacting with you, generating videos or images or text or maybe a digital human. And so you're interacting with your computer almost all the time, and there's always a generative AI connected to that. Some of it is on-prem, some of it is on your device, and a lot of it could be in the cloud. These generative AIs will also do a lot of reasoning capability. Instead of just one-shot answers, they might iterate on answers so that it improves the quality of the answer before they give it to you. And so the amount of generation we're going to do in the future is going to be extraordinary.
So here he introduces NVIDIA's Spectrum-X. This is an Ethernet networking platform designed specifically for AI applications. Think of it as like a super efficient traffic controller for a ton of data. So Spectrum-X enhances network performance by accelerating the processing and execution of AI workloads. This results in faster development and deployment of AI applications. And this is designed for building massive scale AI cloud solutions because it provides nearly perfect bandwidth at scale and extremely low latency. With this Spectrum-X system, he expects that you can eventually group hundreds of thousands of GPUs by next year, and then by 2026, millions of GPUs, all connected and working together seamlessly. Can you imagine a data center of millions of these state-of-the-art GPUs? That's just totally mind-blowing to me. So he mentioned a few names when he introduced the Spectrum-X system. It uses a few tools like this NVIDIA Spectrum 4 Ethernet switch and the NVIDIA Bluefield 3 Super NIC. And so these two components work together to manage all this data. Specifically, the Spectrum 4 Ethernet switch is used for load balancing, and this is important for managing communication between a large number of GPUs. And then this Bluefield 3 Super NIC, this is an accelerator designed for massive parallel computations. Again, we're talking potentially millions of GPUs at once. So anyways, these two components of the Spectrum-X work together to deliver high performance and scalable compute. And this is a game changer in the field of AI networking because it allows businesses to effectively scale their AI infrastructures to potentially hundreds of thousands or even millions of GPUs.
Hopper platform, of course, was the most successful data center processor probably in history. And this is just an incredible, incredible success story. However, Blackwell is here, and every single platform, as you'll notice, are several things. You've got the CPU, you have the GPU, you have NVLink, you have the NIC, and you have the switch. The NVLink switch connects all of the GPUs together as large of a domain as we can, and whatever we can't do, we connect it with very large and very high-speed switches. Every single generation, as you'll see, is not just the GPU, but it's an entire platform. We build the entire platform. We integrate the entire platform into an AI factory supercomputer. However, then we disaggregate it and offer it to the world. And the reason for that is because all of you could create interesting and innovative configurations and all kinds of different styles and to fit different data centers and different customers and different places, some of it for edge, some of it for telco. All of the different innovation are possible if we made the systems open and make it possible for you to innovate. Well, Blackwell is here. Next year is Blackwell Ultra. Just as we had H100 and H200, you'll probably see some pretty exciting new generation from us for Blackwell Ultra. Again, pushed to the limits, and the next generation Spectrum switches I mentioned. Well, this is the very first time that this next click has been made. And I'm not sure yet whether I'm going to regret this or not. We have code names in our company, and we try to keep them very secret. Oftentimes, most of the employees don't even know. But our next generation platform is called Rubin. The Rubin platform, I'm not going to spend much time on it. I know what's going to happen. You're going to take pictures of it, and you're going to go look at the fine prints, and feel free to do that. So we have the Rubin platform, and 1 year later, we have the Rubin Ultra platform. All of these chips that I'm showing you here are all in full development, 100% of them. And the rhythm is 1 year at the limits of technology, all 100% architecturally compatible. So this is basically what NVIDIA is building, and all of the richness of software on top of it.
All right, so as I mentioned before, the previous generation of compute and GPUs, it was called the Hopper platform, which includes this H100 chip, which is the most demanded commodity in the tech world. It's very hard to get access to one. But right now, they're already building this Blackwell platform, which is the next generation. This is going to be 30 times more powerful and I believe 25 times more energy efficient than the previous generation. And Google and Microsoft already announced that they will start to integrate these Blackwell chips into their data centers later this year or early next year. And I assume this will be the next heavily demanded chip. I also expect this to be just sold out and really hard to get access to. The tech giants are just going to stockpile these Blackwell chips just like they did with the H100s. And here, Jensen announced that they are also building Blackwell Ultra, which has higher performance than the current Blackwell GPU. But they're not stopping there. They've only announced this Blackwell platform a few months ago, but they're already working on the next generation platform, which he calls Rubin. Now, we don't know any further specs about Rubin at this moment, but expect this to be like orders of magnitude faster and more efficient than Blackwell, which is already state-of-the-art. So this just shows you the insane growth and progress of NVIDIA.
Robots interacting with robots, building products that are robotic. Well, in order for us to do that, we need to make some breakthroughs, and let me show you the video.
The era of robotics has arrived. One day, everything that moves will be autonomous. Researchers and companies around the world are developing robots powered by physical AI. Physical AIs are models that can understand instructions and autonomously perform complex tasks in the real world. Multimodal LLMs are breakthroughs that enable robots to learn, perceive, and understand the world around them and plan how they'll act. And from human demonstrations, robots can now learn the skills required to interact with the world using gross and fine motor skills. One of the integral technologies for advancing robotics is reinforcement learning. Just as LLMs need RLHF, or reinforcement learning from human feedback, to learn particular skills, generative physical AI can learn skills using reinforcement learning from physics feedback in a simulated world. These simulation environments are where robots learn to make decisions by performing actions in a virtual world that obeys the laws of physics. In these robot gyms, a robot can learn to perform complex and dynamic tasks safely and quickly, refining their skills through millions of acts of trial and error. We built NVIDIA Omniverse as the operating system where physical AIs can be created. Omniverse is a development platform for virtual world simulation, combining real-time, physically based rendering, physics simulation, and generative AI technologies. In Omniverse, robots can learn how to be robots. They learn how to autonomously manipulate objects with precision, such as grasping and handling objects, or navigate environments autonomously, finding optimal paths while avoiding obstacles and hazards. Learning in Omniverse minimizes the sim-to-real gap and maximizes the transfer of learned behavior. Building robots with generative physical AI requires 3 computers: NVIDIA AI supercomputers to train the models, NVIDIA Jetson Orin and next-generation Jetson Thor robotic supercomputer to run the models, and NVIDIA Omniverse, where robots can learn and refine their skills in simulated worlds. We build the platforms, acceleration libraries, and AI models needed by developers and companies, and allow them to use any or all of the stacks that suit them best. The next wave of AI is here. Robotics, powered by physical AI, will revolutionize industries.
And finally, he mentions Omniverse and robots. So the Omniverse is basically a digital twin of the real world. It's a virtual environment that simulates the physics of the real world. And the benefit of this is you can train robots in this virtual environment for millions of rounds of iterations. And then in theory, once you deploy these robots to the real world, they should work as expected. Now, NVIDIA is partnering with a ton of humanoid robot companies so that they can train these robots in this virtual environment, which they called Isaac Sim. And the benefit of training these robots in these environments is it's very low cost, right? Everything is just digital. So you would save a ton of time and money and effort compared with if you were to train these robots in the real world. And so you can see they're partnering with robot companies like Agility. So here's the Agility's Digit robot. Here's Apptronic's Apollo. Here is the Fourier Intelligence GR1. In fact, if you're interested in learning more about humanoid robots, I highly recommend you check out this video where I go over all the humanoid robots out there right now. So you can see this Isaac Sim is a great way to train robots to perform potentially very complex tasks. For example, here you can see that NVIDIA has trained this robot to balance on a yoga ball. And this robot was only trained in a virtual environment. It was never trained in the real world. But you can see it's able to balance on this yoga ball very nicely. So all in all, with this platform, just expect these humanoid robots to learn very quickly. And I expect by the end of the year, we are going to see these AI humanoid robots being deployed commercially, most likely in like warehouses and manufacturing, but potentially in other industries such as healthcare or even in our own homes. So these are just really crazy and exciting times. Anyways, that sums up NVIDIA's keynote at this Computex event. Let me know what you think of these announcements. Which one is most exciting to you? And as always, if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, we built a site where you can find all the AI tools out there, as well as find jobs in AI, machine learning, data science, and more. Check it out at ai-search.io. Thanks for watching, and I'll see you in the next one.